Hello, welcome to another video for the Intellisaurus robot. This video is going to be about making a few custom cables for the Intellisaurus robot. This battery harness is the first thing we're going to make and the most complicated piece. The first thing we're going to do is cut this 3-inch line and splice the ends. We're going to connect this to a USB connector that we're going to use to power the Raspberry Pi. So make sure you've got the right positive and negative connectors for whatever USB you've chosen. There's a couple different on the market. This one's got 4 pins. Some of them have 5, some of them have 3. Now that we've soldered it, I'm going to put a 90-degree angle in it because that's how I want it to connect. There's a 3D printed part here to cover this end, just to make it a little bit more robust. You can pull it in and out of your Raspberry Pi easily. So I'm going to super glue that 3D printed part in to hold this 90-degree turn. Now I'm going to shrink wrap that in just to help cover those ends a little bit better. Alright, now I'm going to add this voltage regulator. This is a 5-volt regulator that I'm going to use for the Raspberry Pi. The two 18650 batteries put out voltage from 8 volts down to about 6 volts. We call it a nominal 7 volts. The Raspberry Pi wants 5 volts, so we need this voltage regulator. Just make sure you've got the positives and negatives and ins and outs wired correctly. Right, so the out is going to be to the Raspberry Pi, and the in is, of course, going to come from the battery pack. Cut another 7-inch piece of wire strip, and we're going to attach that to the inputs to this voltage regulator. Now we're going to just trim these ends off so that they're not poking around. Particularly not going to poke through our heat shrink. I'm going to put this whole thing in heat shrink just to protect it. Now we're going to attach the battery harness. We're going to cut this line about 4 inches off of the battery, preload our shrink tube there, and solder the positive on one side of our main switch. The next thing we're going to add is the 5-volt regulator for the motors themselves. This is also another 5-volt regulator. Notice this one's a little bit beefier because the motors are going to pull more power. Both of the voltage regulators are rated at 3 amps, but this one and the one I've chosen for the Raspberry Pi. But the one for the Raspberry Pi I really think is more of a peak 3 amps. I don't think it can sustain 3 amps. Notice it's a lot smaller than this one. This one really can sustain 3 amps. So we're using this just for the motors. So we're going to cut about 2.5 inches off each side and tin the ends. This is the connector for the Arduino. The Arduino has its own voltage regulator built in, so we don't need to add one on this line. It really can't handle much more than the Arduino itself, so I don't like pulling power off of the Arduino for anything else if I can help it. So now I'm going to twist all of the positives together for those 3 devices and connect them to the other side of the switch. We're going to cover this up with some shrink tubing. And now we've got all the positives from our battery through the switch and then to the various primary components on the robot. Now we're just going to tie all the ground connectors together. I like to use these low temperature solder shrinks, sort of an all-in-one solution. They're great for any sort of splicing you're doing. I've never had them fail. They always work. They are a whole lot easier than trying to solder the wire together first and then move the heat shrink over top of them. So for these things, all you need is the heat gun. Just keep applying heat until the center solder melts. You'll see it melt like this. You don't need to use a soldering iron at all with this. By the time you've applied enough heat for the center solder to melt, the shrink tubing around has also melted down and created a nice watertight seal. There we go. That's our battery harness. Now we're going to make this I2C bus. There's 2 devices that use I2C, the controller for the motors and the accelerometer board. So we've got to splice these wires together. We're just going to cut a 6.5 inch line. Notice I've pulled this out of a larger set of ribbon cable. I like to use this color set for I2C because I've got red for positive, brown for ground, and then I've got 2 colors for data line, yellow and orange. Cut 2 3-inch pieces off, and then we're just going to use those same low temperature solder connectors to solder these together. Again, I love these, they work great. Now we're going to make a data line. This is the data line that connects the signal between the Raspberry Pi and the Arduino. We're only going one direction, so we're only using one line. I'm only ever signaling from the Raspberry Pi to the Arduino. So this is a groove connector that you can buy online. This is the special connector that the Reseed audio board uses as its external connector. They use it for both I2C, but in this case they also use it for the GPIO pinouts. I'm not going to connect the power between the Raspberry Pi and the Arduino that's connected through the battery harness we just built, so I'm going to remove the power lines out of this connector. I really only want a single connector. And now I'm just going to cut a 10-inch jumper cable and use the same splicing cables to go between those two. Just make sure you've chosen a different color. This is blue. By the time you've wired this whole thing through the robot, you want to know that the color of the cable that's coming from the Raspberry Pi to the Arduino. Okay, so that's our special cables for this Intellisaurus robot. I hope you enjoyed that and were able to make these cables without too much difficulty.